Okay, so this is my part 1 to the project. And what I was given was sine of alpha minus beta, sine alpha plus beta is equal to sine squared alpha minus sine squared beta. And to prove this, I think what would be easiest is to expand the left side. I think it would be a lot easier to get this left side to look like the right than the right side to look like the left. And the first step in expanding is what I notice is sine alpha minus beta. And if you use one of the sum and difference formula that we have for sine alpha minus beta, then you're going to find out that sine alpha minus beta is going to be sine alpha cosine beta minus cosine alpha sine beta. And if you do the same thing to this sine alpha plus beta, same thing with the sum and difference formula, you're going to find that sine alpha cosine beta plus cosine alpha sine beta. So we've expanded this, and this is what we're going to find with using this left side. So this looks a little complicated to me. So what I'm going to do is I'm going to make sine alpha cosine beta x and cosine alpha sine beta equal y. So this is going to be x minus y. And this side is going to be x plus y. And if you use the difference of squares law that we have, so difference of squares, you're going to find that if you FOIL these, then this is going to be x squared minus y squared. So if sine of alpha cosine of beta is x, this is x, and this is y, cosine alpha sine of beta, then you're going to find that this is going to be sine squared alpha cosine squared beta minus, because minus right here, cosine squared alpha sine squared beta. So this is looking a lot closer to the right side, but I want to get rid of these cosines. So the way that I'm going to get rid of these cosines is by knowing what cosine equals. So cosine squared is equal to 1 minus sine squared. So if we know that, then we can make this sine squared alpha 1 minus sine squared beta minus, keeping with the trend here, minus 1 minus sine squared alpha sine squared beta. So this is looking a lot closer to this already. But what we need to do from here is distribute. So if we distribute sine squared alpha to 1 minus sine squared beta, we're going to see that that is equal to sine squared alpha minus sine squared beta, sine squared alpha, minus sine squared beta plus, it's going to be plus because of this right here. You're going to have two negatives, a double negative, and that's going to make a positive. So that would be plus sine squared alpha sine squared beta. So the first thing I notice is that we have a negative sine squared beta sine squared alpha here, and a positive sine squared alpha sine squared beta right over here. So these equal the same thing, but they're opposite. So these are going to cancel out. So what is left is we have sine squared alpha minus sine squared beta, which is exactly what we have up here. And so these are going to prove each other.